Hello all. In this session, we discuss about ultraviolet spectroscopy in instrumental method of analysis. So we know what is spectroscopy. It is a branch of science that deals with the study of interaction of electromagnetic radiation with matter. It's a powerful tool to study the atomic and molecular structures, and we can analyze a wide range of samples. There are two main types of spectroscopies. One is atomic spectroscopy, which involves the interaction of electromagnetic radiation with atoms. And molecular spectroscopy is another type in which the interaction of the electromagnetic radiation with molecules. So in this, the important aspect is the electromagnetic radiation. What is electromagnetic radiation? It was discovered by Maxwell and first proved by Hertz. It is a discrete packet of energy, which we call it as photons. So, in other words, we can say that it is an oscillating electrical field and magnetic field which perpendicular to each other. Now, with this help of the introduction about this electromagnetic radiation and the two types of spectroscopies, we get into what is ultraviolet spectroscopy and its principle. The principle is based on the measurement of spectrum of a sample containing the atoms or molecules. Spectrum means it's a graph which gives the intensity of observed or emitted radiation in terms of frequency or with the wavelength. So spectrometer is an instrument designed to measure the spectrum of the compound. The picture depicts the various types of electromagnetic radiations, starting from the cosmic rays, gamma rays, X-rays, ultraviolet rays, visible rays, infrared, radio waves, and in these, the ultraviolet rays ranges from 100 to 400 nanometers. We classify them into a short ultraviolet wave, middle wave, and a long wave from 100 to 400. So these are the different types of possible electronic transition that can happen when an electromagnetic radiation is interacts with the atoms. So when the atoms absorb this energy and they transit to various energy levels, it can move from sigma to sigma star or 5 to 5 star, n to 5 star or n to sigma star or sigma to 5 star and 5 to sigma star. So these types of things are classified into bonding and anti-bonding. So based on this transition and the amount of energy which is observed for this particular transition gives information about what is the type of a chemical which we are doing the analysis. So at room temperature, all the atoms, they have an energy level in a ground state, that is E0. When it observes the electromagnetic radiation, particularly here the ultraviolet radiation, these electrons will be promoted to a higher energy level by observing some amount of energy. So for example, if the electrons moves from sigma to sigma star, we call it a sigma to sigma star transition, which involves a single bond. The absorption will be a maximum at 125 nanometer. With the help of this reading, we can understand there will be a single bond which involves sigma to sigma transition. Same way the 5 to 5 star transition and n to 5 star and 5 to 5 star transition. So the sigma and phi represents, sigma represents the single bonding electrons, phi represents the double bonding electrons, and n represents the non-bonding electrons, which are free in an atom, moves to an energy level of 5 stars. So this is a block diagram of the ultraviolet spectrophotometer. There is a source, the source in which gives a light which passes through the monochromator. Monochromator with the help of a prism or grating which filters all the radiation and allows the radiation of a desired wavelength which we need to be analyzed. and the sample, it's passed through the sample, and the sample will observe certain amount of radiation, which involves the principle which I discussed just before for the transition. And a part of thing will be coming out, taken by the detector. The detector is usually a photomultiplier, detects it, amplifies it, and gives to the recorder. From the recorder, we can analyze the type of the substance which we taken for analysis. So this is another example diagram for that. So the source gives a desired wavelength, a wavelength selector which selects a wavelength to analyze depending upon our requirement. The sample container, we call it as cuvette, a transparent container, and a detector is a photoelectric transducer. It converts the radiation into electrical signals. So from the electrical signals, taken to the amplifies, and the reading will be recorded. So source is different types of source for ultraviolet and visible: deuterium lamp, hydrogen lamp, tungsten, xenon, mercury, etc. And the monochromator filter, there is two types of filters. One is interference filter, and another one is absorption filter. The monochromator, in which the entrance slit have two beams, it falls over the grating, converted into different things, and a desired wavelength can be taken out by using a focusing curve. The sample compartment, usually it's made up of an optical glass or a quartz material. It will be transparent at the two end, and it is opaque at the other two end. The opaque region is for us to hold the cuvettes, and the other two transparent end will be allowing the light to pass through it. Here, in which we add the chemicals which we want to analyze. The detector, usually here we use three types of detectors, particularly the photo multiplier is a convenient one, which works on the principle of the photoelectric effect. When the light falls on it, it emits some electrons, it converted to some electrical signals. These electrical signals are get amplified and it is taken to the recorder. And there are various applications of this ultraviolet spectrophotometer. It used to detect the impurities present in inorganic and organic chemicals. By measuring the standard peak and observance, we can analyze that. For example, the first graph is a standard paracetamol medicine graph. Here, there is another sample which contains some impurity in the paracetamol, which will be easily detected, in which the first one at the end of the graph, at the end of the spectrum, usually we call it a spectrum, there is a straight line. But in the second one, at the range of 1000 to 400 nanometers, there are some peaks which explains that there is a presence of some impurities. And we can also elucidate the organic compound structure. For anthracene and naphthalene, it contain different structures. For different textures, we get a different spectrum. So based on that, we can understand the difference in their structures. And as we discussed, we can do the qualitative analysis as well as we can also go for a quantitative analysis by using these Lambert's law. We prepare different standards and we put a graph for the observance of ultraviolet. We get a straight line. So when we get a straight line, the unknown sample can be detected here. So the qualitative analysis can be done by using this. And chemical kinetics, the rate of the chemical reaction can be easily understood. And the functional group can be detected like this. So the bend in the peak represent the methyl group. And there are several peaks in the spectrum which will given for a benzene. So usually it is used in pharmaceutical analysis to analyze the amount of the drug and type of drugs. Thank you.